Though all life on Earth likely began in the oceans, we as human things know that our domain is not underneath the waves. Only a humanoid hero like Aquaman can survive everything that the seas have to throw at us. Or can he? Can Aquaman drown? Let's get technical. Being half Atlantean, Arthur Curry or Aquaman has the physiology, canonically speaking, to thrive both inside and outside of water. So asking a question like, can he drown, will depend entirely on our definitions of drowning and his physiology. And I know that this question sounds like it has an obvious answer to it, but this analysis turns out to be surprisingly complicated. So let's start with the basics. How does Aquaman breathe underwater? I'm a shark. Whether in water or in air, breathing fundamentally comes down to one process: gas exchange. All particles in the universe, like atoms and molecules, if they have any temperature at all, they are necessarily bouncing around and wiggling all over the place. And as they do this in some volume, for instance, they bump into each other and against the volume, and they tend over time to move into spaces with less particles in them. This tendency is called molecular diffusion, and it makes breathing possible. In breathing things such as we, biology has evolved to take advantage of this passive movement of particles from one place to another. It requires no energy. For example, when we breathe in that air, there is more oxygen in the air than in our body's tissues in our lungs. And so some of that oxygen goes across and through those tissues and into our bloodstream. And the opposite happens with carbon dioxide. And if you looked inside our lungs, the basic structure would be like this. It wouldn't be just a flat interface. It would be a lot of small pockets that would increase surface area available to the air to enhance molecular diffusion. And in gills, like in fish, you would see just the opposite, with those structures and that increased surface area in direct contact with the water for the same reason. But breathing with water changes a lot more than just this basic shape. Hip. I landed on a bird. When his superpowers aren't just glossed over, it's sometimes mentioned that Aquaman breathes underwater using gills. Hello, fish friend. Aid us on our learning quest. If we looked inside our fish friend's mouth and head here, we would find rows and rows on the outside edges of what are called gill filaments. And these are just sections of very, very thin tissue with a lot of blood running through them, positioned such that as the fish moves through the water or opens its mouth, water comes into direct contact with them. And if we looked even more closely at these gill filaments, we would see that yes, they are in direct contact with water, but the blood flowing through these filaments is actually flowing in the opposite direction that the water is flowing, at least in Chad the Shad here. Okay. This counter-current flow evolved because of efficiency. Let's say we had some concentration of oxygen dissolved into the water. Let's say it starts at 100 and it ends in 5 after it passes the gill filaments. As long as these two flows are counter to each other, there will always be a gradient that helps molecular diffusion. If the deoxygenated blood comes into contact with the more deoxygenated water rather than the other way around, because that would not have as good of a gradient and you wouldn't be able to breathe underwater as well. And that is important because, relatively speaking, getting oxygen out of water is kind of hard. Woo, my man! Here I have two 1-liter cubes filled with both water and air. In the probably regular air that you're probably regularly breathing right now, there is around 210 milliliters per liter of oxygen in it. In 1 liter of fresh water, though, there are only 8 milliliters of dissolved oxygen available to a fish. This is in part why gills evolved to be so dang efficient. Not only is there less oxygen available to a fish in water compared to air, water is obviously a lot more dense and a lot more viscous than air, making it harder to move physically past structures like gills. We breathe via molecular diffusion too, but our lungs didn't have to evolve to be so efficient because there's so much more oxygen in the air that we breathe. If fish and their gills are so good at getting oxygen out of water, though, you might be asking, what's stopping them from breathing on land? Jeez, I'm sorry, Gary. I didn't look where I was jumping. What will determine this DC drowning all comes down to Aquaman's form and function. Water isn't just important for fish either. Every single breath you take is first warmed and humidified. More water is added to it before any oxygen makes it into your bloodstream. And we have a consistent, thin, liquid layer covering all of our lung tissue at all times. All of this is to say that dry, breathy bits are bad for living. And this is a big reason why fish out of water have a hard time staying alive. But with a simple demonstration, I can show you the biggest reason. The biggest reason why fish suffocate out of water is because of what happens to their gills when you take gills out of water. So to demonstrate this, we have a science tube here filled with fresh water, and here is our representation of gills. It is just torn up tissue paper because gill tissue is very thin. There's a lot of gill filaments, and as you can see, they present a lot of surface area to the water. And if we submerge this tissue paper in our water here, just like a fish's gills, you can see that everything spreads out, exposing all of that critical surface area to the water. The water's density and viscosity helps keeps everything apart, and the fish is breathing just fine here. But now watch what happens when I take our paper out of the water, just like taking a fish's gills and the fish itself out of the water. You can see that instead of staying spread out, everything clumps together. Weighed down by the water and without any buoyancy, our gills stick together, and look at the difference in the surface area here. Instead of having many different channels available for molecular diffusion, you have basically just two sides. A huge decrease. This is what happens to a fish when you pull it out of water. All of its gills stick together, which dramatically reduces its ability to take oxygen out of the environment. This is the biggest reason why your typical fish will not survive very long when on land. In terms of gas transfer, this is like asking someone to breathe after putting a hand over their mouth. And this is such a simple and understandable demonstration of this fact that I wish I would have gotten my feet wet more often with these kinds of questions when I was a kid. It's an idiom! Of course, not all aquatic organisms have such a hard time with living on land or with dry gills. The mud skipper, for example, can absorb up to half the oxygen it needs directly through its skin, and many species of catfish can just straight up gulp air and absorb oxygen in their guts, and then they just fart out the rest. Given the diversity of respiratory solutions in the animal kingdom, and who knows how Aquaman breathes from comic to comic, whether or not Aquaman can drown is now going to depend on our definition of drowning. Not that kind of definition, dude.
My man.
Merriam-Webster's dictionary defines to drown as suffocation via submersion, especially in water. Suffocation, of course, meaning a deadly lack of oxygen. Given this specific definition, is there a way to drown Aquaman? If Aquaman used gills like your typical fish, there is a way for him to suffocate via submersion in water, and that way has everything to do with what's called dissolved oxygen. We've already talked about how oxygen can dissolve into water in specific concentrations as a gas, but that concentration can change. For example, if you wanted to populate a fish tank with a lot of fish, you would need to increase the amount of dissolved oxygen in the water with something like your standard bubbler. But you can also decrease the amount of dissolved oxygen in the water by adding more fish or by adding more things that require oxygen to break them down, stuff like organic pollution. When a lot of new organic material or chemical pollution enters an aquatic ecosystem, microbes like algae rush to eat it, using oxygen as they do so. And if the pollution is bad enough, there is enough algae that the dissolved oxygen goes down so much, there can be literally no oxygen in the water left for anything to breathe. Chad, no! Depleting the world's oceans of oxygen sounds like a supervillain plot you'd find in a comic book, except we're doing it right now. Thanks to organic pollution and chemical runoff from agriculture into the sea, for years now, there has been a massive dead zone in the United States the size of New Jersey in the Gulf of Mexico. The dissolved oxygen here in this water is so low that almost nothing can live there aside from the algae that created this situation thanks to us. It can be incredibly impactful to the environment, and it is, and dead zones happen like this all over the world, and if Aquaman really existed, he would be really angry about this. But appalling ocean pollution aside for a second, if you threw a fish into dead zone-like water, it would suffocate via submersion in water. It would drown. The last variable here is, of course, how Aquaman actually breathes. But whether he is absorbing O2 through his skin or using gills, or he needs to occasionally return to the surface to gulp some air, there should be a way he can drown. If Aquaman used gills like your typical fish, a supervillain could simply create a dead zone in all of the oceans or in his Atlantean home that would lead to lethal levels of dissolved oxygen. Or if he gulped air from the surface, you could simply deny Aquaman access to the surface and he would eventually drown in the water. This actually happens to fish that we know about, like the betta fish or Siamese fighting fish. And if he absorbed O2 through his skin, you could just do a combination of both. Aquaman can drown. Hey, get up. You can't be dead. You have to save the DCEU with money. So, can Aquaman drown? Well, it sounds like a silly question at first, but once you know how fish actually breathe and how they depend on oxygen just as much as we do, you can think of situations where if nothing magical is going on, yes, Aquaman could drown. He may be the king of the seven seas, but he's still subject to almighty O2, just like you, just like me, and just like Gary. Because science. Don't you have like a parking lot to be annoying in? As a child, I do not think you have a fundamental understanding of what dissolved oxygen is. Why would you have one? And so that's why your goldfish died. That's why my goldfish died. You assume that the water is what allows the fish to live, but you don't realize that there's dissolved oxygen as a resource, a finite resource in that water. And so if you just keep a fish in just a small bag or just a small bowl where oxygen is entering the water from the atmosphere but not enough, there won't be enough oxygen in the water and the fish will suffocate or drown by our definition in that water. So that's why your goldfish died, and that's why you need a bubbler. And that's why I was a sad boy at the county fair. Thank you so much for watching, Aaron. If you like this video, you might like some of our other sciencey Aquaman-y videos that we've done, like how he swims supersonically through water and how his body, ripped though it may be, survives the sea. And if you want to give us suggestions for future episodes, one of you suggested this episode, you can follow us here at these social media handles. And hey, all right, okay, my man, can dig it like a bat. Shave my beard. Who knows? Call Drogo.